Hi, welcome to this video whereby I want to show us how we can get the angle between two curves which are intersecting as shown in this sketch here. So we have this curve which is given by y is equal to f of 1 of x, and the other one is given by y is equal to f of 2x. So the angle between the two curves is equal to the tangent is equal to the angle between the intersection of the tangent between the two curves. And of course, you know how you obtain the tangent on a curve. It is the perpendicular line drawn at a point along the curve. So when these two tangent line of the curve intersect, the angle between them, it is now the angle between the two curves. Now, the angle between two curves is given by the tan inverse, whereby now, first of all, you get the gradient of curve 1, you subtract the gradient of curve 2, and you divide by 1 plus the product of the gradient of the two respective curves. Here, we are going to illustrate this using a simple example whereby you are told to obtain the angle between two curves, and you are given one of the curves is y squared is equal to x, and the other one is x squared is equal to y at point 1, 1. So first of all, we can call this one of our function. We can call it f of 1, which is equal to y, which is equal to x squared. So what we are going to do here, we are going to differentiate f of 1x with respect to dx. So this one will be dy of dx, which will be equal to 2x. Now, to obtain our gradient, we are going to get dy over dx at this point here at 1, 1, meaning that this means that the first component here, 1, corresponds to x. So we substitute here, you have 2, where you have x, you substitute with 1, which is equal to 1 times 2 is 2, meaning that our m1 is equal to 2. Next, the second part is we can call this function f of 2 of x, which is equal to y squared, which is equal to x. So we differentiate f of 2 with respect to dx, meaning that we will have dy with respect to dx. So here, when we differentiate this one, we are y squared, we are going to get 2y dy over dx. This is an implicit differentiation. On how to do to differentiate implicitly, you can check in the link below or in my YouTube channel, and you are going to get and to find a number of examples on how to differentiate a function implicitly. When you differentiate x with respect to x, you are going to get 1. So you can divide this both sides by 2y to be left with the dy over dx is equal to 1 over 2y. So our gradient dy over dx at the point given here is 1, 1. At point 1, 1, we will be given by 1 over 2. You multiply by 1. The value of y is 1, which is equal to 1 over 2. So our m2 is equal to half. Then from there now we are going to make use of this formula. The angle which we are told to obtain, the angle between the two curves will be given by this formula. We call it theta is equal to tan inverse of m1 minus m2 divided by 1 plus product of M1 and M2, which is equal to, we substitute tan inverse of, our M1 is 2, so you have 2 minus half divided by 1 plus 2 multiplying by half, that way, which is equal to tan inverse of 2 minus half is 1 over 2 divided by, this is 2 times half, there is a times here, 2 times half is 1, 1 plus 1 is 2, which is equal to tan inverse of 3 over 4, because reciprocal of 2 over 1 is the same as 1 over 2. So from your calculator, you can obtain the tan inverse of 3 over 4. So the angle between the two curves from the calculator will be that 6.87 and degrees, correct to 2 and decimal places. So I want to give you a simple exercise for you to attempt, and also after attempting, you can send the solution so that I get to know. You are going to get the angle between two curves, the angle between two curves given by y1. Y1 is the first curve, is equal to a power x, and y2, that is the second curve, is b power x. Int here is that at point 0, 1, at point 0, 1. So the int here is to know how to differentiate exponential function. So you can check in my YouTube channel, whereby I have done on how you can obtain the differentiation of an exponential function of this kind. But I can give you an int dy1 over dx will be given by a power x natural logarithm of a. When you differentiate this exponential function, we will obtain this result. This other one, dy2 over dx will be given by b power x, or b power x natural logarithm of b. Then to get m1 will be given by dy over dx at the point which I've given you there is 0, 1. Then you substitute, it means that the value of x is 0. So you substitute here, you have a power 0 natural logarithm of a, which is equal to, any number power 0 is 1. So it is 1 times natural logarithm of a. That one will give you natural logarithm of a. Then this other part here, m2 will be given by dy2 over dx at 0, 1, at that point is 0, 1, which is equal to b power 0 natural logarithm of b. This is equal to natural logarithm of b. So now you substitute in this formula here to get your result. So thanks so much for studying with me on how to obtain the angle between two curves. For more examples, tune on to my YouTube channel so that you may find other related examples of this nature, and so that you don't miss other subsequent videos which I upload for you every day.